Hi everyone. In this video, we will be discussing about parsing in Haskell. More specifically, we will be discussing about a parsing library called Megaparsec. Now, there are several parsing libraries available in Haskell, such as Parsec, AutoParsec, Trifecta. But Parsec is one of the popular ones. It is very well maintained. So we will be talking about this. And towards the end of this session, we will be also be making parser for a small file type called .ini. So, for example, if I gave it this file, it will parse it and it will sort of decode that there is an audio and it has two configurations, volume and mic. So let's get started. Let me just create uh, uh, folder. Let me just set up the project first. I'm going to call it practice Megaparsec Cabal init. Make sure you have Cabal, GHC, everything installed using GHCF. Library plus executable. Okay, all the default stuff. We'll take the latest thing. There is text source. Okay, all done. We don't need this. So let's start Tmux really quickly. Sorry. All right, this is where will our code will start. Let me fire up GHCID, and I don't need this. Okay, all good. Uh, from the .cabal file, let me just add the dependency. So obvious thing, we will be needing Megaparsec, inside of which these are the list of functions. I just want to go through it first. We will not be seeing every single functions, but we will see just enough for you to get started and just enough to create the parser for this INI file format. So let's start so this is a very important thing. So this library suggests us to write a type synonym called parser, which would contain this type parsec, void, and text. So this is basically the type of input stream. It can be text, it can be string, it can be a byte string if you know your input stream is a image or something. And this void states for some custom error input. So for example, if on fading the parser you want to have some error type, you can add it here, but that is really beyond the scope of this session. We will look at that later on. For now, we will just have it as void itself. Later on, so this is not relevant. Yes, running a parser, there is a function called parse that takes the parser function, that takes a string. Sorry, this it takes a name of the source file. We don't really care about this. It takes the input parser, basically the input string, and it will give us an either format, either the error or basically whatever the parsed content. So then there is a maybe format, so it returns the either, and this one returns a maybe. Then parse test is there, run parser transformer variant is there. All these things are there. And slowly we will check all these functions. So let's get started. Let me just quickly add the library in our build depends. And I'm just going to be playing with mylib. Import, what is it? Text dot megaparsec. More specifically, since we will be dealing with strings, let me just copy paste this type synonym here. And instead of text, we will be using string because this is completely for demonstration purpose. Whenever you will write a parser, maybe you should focus on string for performance purposes. And it is giving us an error saying that void does not exist. My assumption is that it is part of data.void. Okay, great. So to begin with, we will be using this particular module called text.megaparsec.char to parse mostly the characters to specific characters. And the most basic one is going to be char. So here it is. So it takes the token and it will return sort of the parsed version of it. I'll explain that. So let me just quickly add that particular module, import that module, and let me write a function. So this is going to be a parsing function that whose goal is to parse a certain character. For example, let's say I'm going to call this function as parse char a. Okay, the type signature would be parsec char. Parse. I'm going to make it capital, but the intention is to only parse the lowercase k. So parse char a, and as it mentioned, there is a function called char. It takes a single token. Okay, in our case, it will be a single a. I think I made parsec char, expecting two more. It should be parser. Sorry about that. Yes, all good. It is saying that define but not use parse char a. So this is a function that tries to parse character a from the input stream. So let's try and running it. I'm going to say cabal REPL. Okay, I'm going to import, what is this? Mylib. Then I'm going to import text.megaparsec, and I'll tell you the reason why. So in text.megaparsec, in running parsers, we have a function called parseTest. What it does, it takes the parsing function. It takes some sort of the input stream that is nothing but the input string, and it is returning in IO. The reason is that what it will do is it will take the parser, it will apply that parser to the input, and it will print whatever is the output, whatever is the parsed content. And if it fails at parsing, it will give the error as well. So it is perfect for us. So let me just look at the type as well. Parse, what is it? parseTest. Okay, so it is that. So what I'm going to do is I'm going to apply parseTest with this parsing function, and I'm going to give it some input stream. ParseTest. The function name is parse.char a. Parse.char a. And the input stream. Now we want to parse our character a. So let's just give it that. It worked. The output is basically whatever the thing that got parsed. What if I gave it AB? It parsed again because our parse.char a function is only looking for one character, and it only checks whether that character is A or not. It doesn't care about the remaining input. It only returns the single character. What if I gave it ABC? What if I gave it AA? It will still only parse the first character, and basically our parser pointer is now pointing at the second character. It is pointing at this character. I will explain that bit in a second. So now what if I typed C? Okay, it gave us an error saying that unexpected C, it was expecting A. So our parsing function, as I mentioned, it was expecting an A, but from the input stream, we had C. What if we have CA? What if we had AC? For AC, it worked. Interesting thing, very important thing. What if there is a space and then there is A? It still gave an error because a space is still a character. So that was interesting. We can do the same thing for, let's say, there is another, I want to have parse_char B. That will parse the character B. Let me reload this. Parse_char B, it will give us an error. For B, AC, it will parse it. You will be thinking, yeah, there are these two parsing functions, which are, very small parsers. They are parsing one character, only one character, and only checking whether that character is this specific character or not. The great thing about parsing, more specifically parsing in Haskell, is that you can combine multiple parsers together to make a more powerful parser. I'll show you that. So if I decided to write parse_char AB, and this time it will return a parser_char. Okay, that will be parse_char AB. And first, I'll call the function parse_char A, and then let's use the do notation. And then I will call parse_char B. With this, I sort of combine two parsing functions into a single one. Let's try running it. What was it? Parse_char AB. It gave an error because the first thing that it was expecting was A. The second thing it is expecting is B. So if I just gave it just A, it parsed till A, but our input ended. So it got end of input, but it was still expecting B here. If I gave it AB, it will work, but a strange thing will happen. And that is, it is only returning us B. Why is that? That is because we passed A, then we passed B, and we return whatever the content that got parsed by this function parse B, by the last function. We don't want that to happen. We want to get the content of parse A function and the content of parse_char B function, and we want to basically return the combined string. So first thing that we need to change is parser string. Okay, now it is giving us an error saying that parse_char B is returning a character, but what you are expecting is a string, that is the list of char. So how to do that? The answer is pretty simple. We will take the output of parse_char A into something. I will just call it char A. Same for char B. We took both of these out. Let's see what error we are getting. The last statement in a do block must be an expression. So we are going to return char A and char B. We'll first need to combine it. This is not the best way to combine, but we'll use it. So we are making the list of two characters. Now let's try AB, and we got AB. So that's how you can combine multiple parsers. This is again a very small, simple example, but it is a very effective one. You can combine multiple small parsers to make a more powerful parser. And that is really the essence of these parsing libraries. So we saw characters. by using these characters, we can actually parse a string, you can see. But yeah, it can be very boring. If I have to parse a string for a cat, I would have to type char c, then char a, then char t. After all that, I would be able to parse the string cat. So there's a simple solution for that. Simpler solution, that is, there exists a function called string. Just like for char, it is a synonym for the function called chunk. Let me just see. This chunk is part of. Okay, text.megaparsec. Fine, we will use this string function. So I'm going to say parse cat, parser string, parse cat. It will be string cat. So, okay, instead of writing stuff here itself, I can just have parseTest. Since it is a very small parser, obviously we will be making some large code as well. So it's going to be string cat. So interestingly, it gave us an error because it is not able to understand this. There is a string function and it is returning a monadic type of tokens. Now it is not able to understand what is the exactly the type of tokens. So to avoid that, let's just use this. I'm going to do this. Then the function name I think was parse cat. Okay, it worked. Now the next now let's see some more functions. So there is the ASCII character for the 128 characters of the Unicode string. Then there is a symbol. Let's try symbolChar for a second. SymbolChar. Okay, let's try it here itself. So symbolChar, and yeah, so it is not taking anything. So it will parse anything that is a symbol. So let's see. Oh, so I think I can direct. Can I? No, I don't think I can use it directly. Parse cat. We gave an error. It is saying that it is expecting a symbol. So let me just give it a symbol. Dollar. It worked. Something else. And okay, I don't think and is a symbol. What about at? At is also not a symbol. Okay, dollar is fine for now. Let's see. There is a number char. Before the number char, I just want to explore another thing, that is a digit char. So parse an ASCII digit that is between 0 to 9. This is going to be a very important. Let's try digit char. Digit char. Okay, fine. And what about number char? Parse a Unicode numeric character including various scripts. Okay, so it may be able to sort of parse some Roman numerals as well. So that is interesting. And then there is this function printChar that can print actually that can parse actually any sort of printable character. That is also interesting. What function that we will be using mostly is called alphanum character. So it can parse alphabetic as well as numeric characters. So you can simply think of it as the combination of digitChar and ASCII-char. Then upper char and lower char. Let's just try to use and all of this. So what? And we can actually combine all these small functions together to actually make something big. So what I'm expecting from this parse cat function is that first I will expect a symbol. Okay, some sort of a symbol I'm expecting. and I'm just going to call it sim. Then what I'm expecting is a upper char. Then I'm expecting a lower char. Then a digit. And finally, what is it? Let's just use ASCII char for the sake of using it. Uh, A, B, C, D. So all these are characters. And I'm just going to return. I don't know how do I combine it. Okay. So parse cat, sorry, parse test, parse cat. So the first thing is a symbol. So the only known symbol is dollar, then an upper character, capital a lower character, small a. Then we have a digit, let's say 2. Then we have an ASCII character, let's say B. And I think that's all. It got parsed. If I wrote anything different, like I missed this, it will give an error. It is saying that we got 2, but we were expecting a lowercase character. So you can think of it. So this is actually great. You can actually work out something meaningful, something powerful from this stuff. Um, so these were some functions from the character um, module. There are some other functions called a space, though you need to remember that it is not returning anything. It is there to skip. Okay, skip 0 or more white spaces. So this is actually a scary function. It can actually go into a while, it can go into an infinite loop if not used carefully, because it will keep on parsing as well as there are many white spaces. Same goes for newline. So newline actually returns that specific character. So let's try newline. So if I hit new line, okay, it is giving that ambiguous error. So what I will expect is that after digitChar, I will get a new line character. Okay, I will get a new line character. I'm just going to call it, okay, yeah. And okay, I don't need to combine it. So reload. Uh, Earlier, I think it was this string. Why it is giving, oh, parse this. Parse this. Oh, sorry. Parse cat. Okay, we got unexpected B, we were expecting new line. So the new line character is /n, and it worked fine. So this was the example of new line. What about, yeah, tab will also work the same, but still, let's add it. Yeah, it returns. So if you don't care about something, we can just write an underscore there. What was that? I think it was after lowercase. Yeah, it worked fine. Then this is important, 0 or 1 more spaces. So what I'm going to do is I'm going to write space here. Okay. And I'm going to reload and I'm going to parse this. It worked fine. Now, if I gave it a space here, it will work fine. If I gave many spaces here, it will work fine. What if I gave, obviously after the space, it will not care because it will, our function only takes stuff until this, I guess, ASCII cat, and then it sort of ignores stuff. What if after a space there is something like another small cat? Oops. So in that situation, I need to add space here, have another ASCII char f, and it worked fine. So yeah, this was all pretty much all the stuff that was most important. And then there is this library called pose. So yeah, we will not much care about pose. So we have parseTest. There are two, yeah, there are some important functions which are part of text.megaparsec module that I want to discuss. First one is label. So label is not there to do anything important, but it can be useful. So for example, if we got any error, okay, if we are getting any sort of error, for example, let's say there is this character A, and when I get an error on character A, it says that expecting char, just give me a second. What is it? Parse A, right? Parse char A. It is expecting A, unexpected space. So instead of saying expecting A, what if I want to give it something different? Label, uh, small character, something like that. If I want to write, let me reload. Okay, I was expecting the small character. It is there just for that. Maybe if you want to have some better meaning at errors, you can do that. You can also hide it. So that is interesting. Let's try hiding it. Hidden. Let's see. Unexpected space. It did not give any expectance. So that is also interesting. Maybe if you want to hide some stuff. Now there is a very important function called try. This is a function that you will be using a lot. So I really want you to emphasize on this. And we will be really using this function itself. Um, so uh, So let's say, and before that, I actually I should discuss about this operator called OR. So I mean, it is getting it is definitely getting re-exported, but I think originally it is part of, let's see, it is an alternative, that is for sure. So it is originally part of, okay, it is part of control applicative. Um, so what is the meaning of this symbol? Okay, so it takes two things. It takes uh, some structure containing of having the applicative instance, another structure having an applicative instance, and it returns the one of the structures having the applicative instance. What happens is that first it tries to evaluate this, okay, and then it tries to evaluate this. If this gave an error, it sort of fails, then this will get evaluated, and if this got succeed, then it will return the result. If this one got succeed, it will never evaluate this, it will directly return this. If both of these fail, then it will return whatever is the failure. So it is a great way of combining two or more parsers in a more powerful way. For example, let's say uh, I want to have this parse cat where I want to parse two different types of strings. For example, if there is a string called like here I'm expecting two types of strings. Either I'm expecting audio or I'm expecting video. So here what I can write is string audio, okay, or there can be string video. Whatever I will get, I will return that. So let's try running it. Parse cat 2. Sorry, parse test, parse cat 2. And if I type hello, it will give me an error and it is saying expecting audio or video. If I type video, it will work. If I type audio, it will work. Now, there is a very interesting thing that I want to show. Instead of audio video, what if I type car and carpet? If I say car, it will get parse. If I say carpet, it is returning car. Now, as I mentioned, the simple reason behind that is uh, with alternative, what happens is that it tries to evaluate the first thing. If the first thing got succeed, the second thing will never evaluate it. Okay, so from the parse string, it tries to apply the string with the first operator. It got succeed, so it never went to check whether it is carpet or not. Okay, even if I type carpet, the first three characters got matched, so it returned car. It never evaluated the second. So you always have to be careful about the sequence of the parsing functions that you are putting in these alternatives. The benefit of this thing is that I want to mention if there is video, uh, audio, and I also want to add another thing, string, let's say image. You can combine as many operators as you want. It doesn't matter how many are there. So let's get back to our car carpet example. So you might be thinking that, yeah, sure, if I can just add carpet here, it will work fine, right? Let's see if it works or not. It worked. Carpet worked. What about car? Car is also working because it tries to parse carpet. It failed, so it went to check for car. Uh, Now let's try with this example, let and lexical. I'll just explain why this one is not working. Let and lexical. Okay. So if I type lexical, okay, it worked. So that is interesting. Parse text. I'm not sure why it is able to backtrack. Uh, let's go here. Let's type this thing. It is giving that whole ambiguity error. Let me just paste it here. Parse cat 2. Okay. So I guess it is internally doing the backtracking whenever we are using alternative. I guess it's in the new version it is doing that, but it can be very helpful in case of we can use try function. So let's say we gave it the input string lexical, and it first tries to check for the parser let. Um, it went until L, it went until E, it checked for T and X, it did not match, it failed. Then it tries to go for string lexical. But here the problem is that it eat up L and E from our input string. So now it is starting at X and then it is trying to parse the L. So that's where things would go wrong. It is, you can see that it is saying unexpected lex, expecting let.
So these type of things can happen. For that, we would have been using try, but I guess try is sort of getting internally used. Note that as of saying backwards automatically. Yes, sorry about that. I should have read this message. So it does not need try. However, our example demonstrates the idea behind try. So well, we decided to keep it. I feel like they should have had it highlighted in the top, but no worries. It's good that we spent some time on it. Anyways, there is a very good function called lookAhead, and it does something that is done by try, but let's see what it does. If P in lookAhead P succeeds either by consuming or not, the whole parser behaves like P succeeds without consuming anything. So what happens is that um, let's say there is a string let, okay, or something like that. We parsed it, okay, and like there is a okay, let's try the example. So parse cat2, let's say there is a string. I want cat, then I want it to be followed by a string dog. And in between, I want one or more spaces. The spaces are optional. So there is, while we are on it, there is a function called space one. Okay, so space is there as part of that skips zero or more spaces. It means that even if there is no space, then it will work fine. But what if I want at least one space there? I will use space one function. It will skip one or more spaces. So I will use space one. Let me reload it. I want cat and dog. Perfect. Doesn't matter what it is returning because it is returning the last thing. You know how to return the whole thing. You can do by doing this. So what I want to do is, let's say I have string cat. Okay, we did this, and then there is a string dog. What if I want this to be parsed? Okay, but I want my pointer to again be at the initial position. Okay, that is cat and dog. Okay, so how to do that? We can simply, let's say I have something like this, and one of the space. Okay, okay, this will work. This will. Okay, it gave an error. It is saying that unexpected dog because cat and a space got eaten by this string and a space. So how to deal with this thing? So what we can do is we can use lookAhead so that even if some input string, even if it got eaten up by some previous parsing combinators, it will still work fine. I need to add some parentheses. I think lookAhead, I have not imported it. So let's see what lookAhead is part of. Or maybe my spelling is wrong. Oh, my spelling is wrong. Okay, so let's try that. Yeah, it worked fine. So what we did, we first parsed the cat and the space, and then we did a lookAhead on it. It means that we went backwards and then we parsed the whole thing again. Now, it can be very beneficial where, as the name suggests, you want to look ahead. You want to check whether some specific characters, strings, some specific symbol exist ahead without first trying to apply the big parser. Okay, so let's say if this is a very costly operation and you don't want to sort of waste it, or maybe you just want to get the idea of what is the type of the next string, you don't want to waste that character, you can use this look ahead function. Same goes for not followed by. It is really the opposite of look ahead. So it will succeed only if this parser failed. Okay, this side of the parser, if it only failed, only then the next parser will work. So let's see how. So let's say if I type cat1, then this part will fail.
Let me try not followed by, not followed by. Okay, we can just do something simpler. Not followed by character Z. This should be inside parentheses. Yeah, it worked. But if there is a Z character at the beginning, it is saying that Z was unexpected. Okay, I think that is really all. Just one last two functions that I want to cover is sum and many, but it seems that they are not here. But anyways, I think we can still use them. So yes, so many and some, these are part of, I guess, control applicative, which is a module that is getting re-exported by text.megaparsec. Um, so this is very helpful. So let's say, as I said, if there is a character Z that I want to parse, and I just don't want to parse a single occurrence of character Z. I want to parse as many, one or more occurrences of character Z. I can use sum function. And if I go here, what was it? Yeah. So if there is a single Z, it will work. If there are multiple Z's, it will still work. Now this was the sum function. There is also a function called many. So what it will do is it will try to parse zero or more occurrences of Z. So if there are these many Z's, it will all get parsed. If there are none, it will still get parsed. So yeah, I think this much is enough knowledge for us to actually get started with our application. That is nothing but the INI file format. So if you look closely here, we have n number of lines. So after a point, there will be a new line. Okay. Then there is something called as type. I would say I would think of it as a config type, like options. Okay, there is just one thing. So let me just write my own INI file. So I'm going to call it test.ini. So it can be something like this. Audio is there. Volume, I'm just going to say 15. Mic, I'm going to say true. And this true is just going to be a string. It is not going to be the Boolean type. Although we can actually parse it into a Boolean type as well. That is also very simple. But for now, let's just think of it as mic as true as string. Then we will have, let's say, video. Let it be a resolution is equal to 1920x1080. You can see we have the combination of digits and string. And then HT is equal to true, something like this. So we can have some n number of options, which would be inside this audio video type. And then we'll have a sort of key value pair, which are separated by the equal sign. The condition to make things easier for us is that there will be no extra spaces. We will not try to cover this spaces or anything. Maybe we'll try to cover if time permits. And yeah, you can expect one or more. Okay, after an option, okay, there will be zero or more number of these configs. Okay, so first let's just write the type for it, like what I want. So first of all, there will be a config name. There will be a config name which will stand for this, like audio and video. So it will be config name, which is just going to be a string. Then there is going to be the key value pair. So I'm just going to call it config, which is going to be a tuple of string comma string. Okay. So volume and 15, mic and true, these are going to be key value pairs. And our result is nothing but going to be
the list, because there will be n number of these configs. It will be a list of tuple of config name and its corresponding config. C capital. Okay, this is, so I want to parse all this. For a sake of simplicity, let me just put all this inside comment box. All good. So from my lib, what I want to do is, let's say there is the content which would, so from a Cabal REPL we will actually read that input file, but for now let's just have it at audio slash n volume is equal to 15 for here. Let Okay, let me just think about it on what we want to do, what we can do. So first, let's just simply think that we have something like this. How can we parse this? So there is a character that is this, the square bracket. Then there are one or more characters. I just want to mention that numbers can also be possible here. Digits can also be possible. And then there is the ending character. So all I can think about is, let me just have a function called parse config name, which would be a parser for string or config name. I think config name would make more sense. Config name. Parse config name. It will try to first grab the character square bracket, and we don't really care about this. We are not recording it, so we will eat it up. Then there will be one or more characters. Now these characters there can be a small character, then can be a large character. So for this we have a very good function called alphanum character. So our digits, small character, large character, everything, not bad, part of it, use, okay. Everything gets covered in from this function. So we will use this alphanum character, but as you can see, it only returns one character at a time. We want one or more. So for one or more, we will be using a function called sum. And this would return us a string that is going to be nothing but our config name. And then it would also end with a character, basically the ending square bracket. And all we have to do is just return the config name. Okay, let's actually try and run this. I'm going to hit Cabal REPL, import mylib, import text dot megaparsec. I'm going to say parse test. The name is parse config name. And this should work. Yes, it perfectly worked. Now, a very simple thing. What if I did sum, that is one or more of these audios? It worked perfectly and it gave me a string. One important thing, what I want is that in between this audio and video, there should be a new line. Okay, so it did not give me an error. It just stopped parsing because it tried to apply parse config, this parsing function, as many times as possible. It failed here, so it stopped. So what I want to do is, I just want to create the sequence so that there would exist one or, no, not new line, one or more new lines. So I think this will give, okay, it worked, but not the way I intended, because this sum got applied to this function only. but I want to be applied on both parse config name and newline. So it will try to parse n number of these config names which are separated by newline. Okay, it gave an error, very interesting error, because it parsed audio, it parsed video as well, but at the end of our input, we don't have a slash in. So we need to make sure that there would be a slash in at the end. And it did not give us anything because that's just how our function is written, but it's not a big deal. We will make that change here. So we have parse config name. So I just want to make sure that the thing is, let me just, what was it? Test.ini, I guess. Yeah. The thing is, we parsed until this point. Then I want to go one line below. So we can do two things. We can either go one line below from this function for the function that we will be writing for a key value pair, or we can parse it until a slash in itself. So for now, let's just forget about the whole slash in thing. We were successfully able to parse the config name. Now we'll just parse the key value pair. Parse config. I'm just going to call it config. Parser config. So how is it? So there will be alphanumeric character, same as this. This would be our key, and then there is going to be our value, which is going to be some alphanumeric characters. At the end, we are going to return it in a tuple, key comma value. It will work, but one major difference is that in between those two, we will have a specific character that is equal sign. So let's just involve that. I'm going to say char equal, and we don't care about that character, so we will just not have it. So I'm going to reload it, and I'm going to say, I think it's parse config, and I'm going to give it a key value pair. Let's say volume is equal to 50. It worked. If I did a new line, if I did sum with parse new line, fashion, what was it? Mike equals 2. It worked. It worked. It just did not print it. So yeah, we also figured out parse config as well. Now we have parse config, we have parse config name. We just want to combine these two parsing functions to make basically our final combinator. So I'm just going to call it final parse or something like that, which would parse, which would be a parser for result. Final parse do. So by means the result, it means that it's basically going to be the combination. It is going to be the list. So by list, I mean that parse config name. This will give me the config name. Then config itself. Now there can be n number of configs. As mentioned here, there can be n number of configs which are separated by newline. So I'm going to call it, I don't know how to do it. I would say configs, and then there will be some number of configs. So parse config, which are separated by newline. And I can't use this. So a simpler way to handle this thing, I mean, obviously I can use a do notation and solve it. A simple notation thing that I can do is parse config, and I can just eat one new line. So there will be n number of configs, and at the end, I'm just going to return. Now this itself, I can just do a sum on this. Return the config name, comma, configs. Configs couldn't match type. It is a list. Okay, so there will be a list. Okay, so it worked, and I don't think so. There is another problem. Obviously, with parse config, we will be stopping here. Okay, we will be stopping here. There is no new line. So we also need to eat the new line here as well. Now this will not work. Now let me tell you why. First, let me just read this read file. Read file into x, print x. Okay. Now parse test. I think the name is final parse. Final parse x. It worked. It worked. I didn't thought it will work because usually what happens is that whenever you read something, now if I take this whole string and instead of this I pasted it here, it will not work because at the end there is no slash n. When you read something from file, I think implicitly a slash n gets added. But here the slash n did not get added. Now, when I was practicing it, I got into this issue, and there is a hack for it, I would say, is that you can just manually add a slash n towards the end of your file. But whenever you read stuff from your file, it will uh, basically it will add a slash n, append a slash n at the end, and it will do the parsing. So yes, that's how you can parse. We built a small parser for a very simple file format. Obviously, not many things have been covered. For example, what if there are more spaces? What if there are spaces in between these three things or and all? We can. These are again edge cases. I think that would be a very good homework. You can practice it. And yeah, I think that's it for this video. Thank you. Bye bye.